Hey class, welcome back to the unit on right triangles and trig. Today we dive into trigonometry. Yeah, buddy. You're going to love it. I promise. I promise. I'll make it easy. We're going to do a few videos, hopefully 2, but I might talk a lot. You never know. And we'll see how far we can go. What we're going to learn about in this lesson on trigonometry is the actual trigonometric ratios. And then we're going to use trig ratios. So I'll probably save that for the next video. But right now, let's talk about what are the trigonometric ratios. Well, of course, we're going to start with notes. Yeah, okay. All right. So here's the note little thing. So we have our trigonometric ratios. Now, there are 3 main ones that we'll deal with when it comes to right triangles. There are more than 3, but there are 3 trigonometric ratios. Now, what is a trigonometric ratio? Well, this is what we should know. A trigonometric ratio is a ratio of segment lengths in relation to a specific angle. All right, so we got to be looking at a certain angle to use a trig ratio, and the ratio is the segment, the ratio of the segment lengths. So that's what a trig ratio is. It's a ratio of lengths in relation to an angle in a triangle. Now, something else that we'll learn about later is that not only can the trig ratios be ratios, they also can be operations, things that we actually do to angles. We can actually do these things to angle measures. Okay, so they are also operations, and we can graph them as well. That's later in trig, and they also act as functions. But that's what a trigonometric ratio is: a ratio of segment lengths in relation to an angle. So what are they? We have 3 major ones that we'll talk about for right triangles. That is sine, cosine, and tangent. Okay, sine, cosine, and tangent. So the way this works, whenever you're looking at a specific angle, in this particular note, we're looking at angle A. So the note in angle A is the note here is in relation to only this angle. Now, when it comes to looking at the angles, we have 3 segments. When it comes to the angle, we have an adjacent leg. The leg that is touching the angle is adjacent. We have an opposite leg. Okay, so a leg that is opposite the angle we're looking at. And of course, our hypotenuse. Okay, so there are 3 types of segments we're going to look at: an adjacent leg touching the angle, an opposite leg not touching the angle, and of course the hypotenuse. So what then is the sine of the angle? The sine of the angle is the ratio of the opposite leg to the hypotenuse. Okay, so the sine is the opposite leg to the hypotenuse, or sine opposite hypotenuse. So the way this looks is it's a ratio. It's in fraction form, opposite over hypotenuse. The cosine of angle A. The cosine then deals with the adjacent leg compared to the hypotenuse. It's the ratio of the adjacent leg to the hypotenuse. Cosine is the adjacent leg to the hypotenuse. And then lastly is the tangent of an angle. The tangent of an angle is the ratio of the opposite leg to the adjacent leg. Okay, so we don't need the hypotenuse for the tangent. Tangent is a very useful thing, but whatever. So the tangent is the opposite leg to the adjacent leg. Tangent, opposite leg, adjacent leg. Now, the way you can remember this, the way I remembered it anyway, is taught about Chief Sokotoa. So, good old Chief Sokotoa is our trigonometry chief. So you can remember Sokotoa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And then tangent, opposite over adjacent. And that is the rough sketch of the trigonometric ratios. Now remember, it has to do in relation to an angle you're looking at. This note deals with angle A. So the way we talk about the sine of angle A, the sine of angle A is A over C, opposite over hypotenuse. The cosine of angle A is B over C, adjacent over hypotenuse. And the tangent of angle A is the opposite over adjacent, A over B. That's the tangent, okay? So let's see if you're paying any attention. Were you paying attention? All right. So what if we changed our perspective? Same triangle. But now we're going to look at angle B. Okay, so let's take a look at angle B. What then would be the sine of angle B? Okay, remember sine is opposite over hypotenuse. Well, here's angle B. Opposite of B is B. And then the hypotenuse is still C. So the sine of angle B is B over C. See how that works? I hope you do. What about the cosine of angle B? Again, we're changing our perspective. We're looking at this angle now, and cosine is the adjacent over the hypotenuse. Adjacent means touching. That's leg A. So the cosine of angle B will be A over C. And then the tangent of angle B. And again, we're changing our perspective. We're looking at angle B. The tangent is, of course, the opposite over the adjacent. Opposite over adjacent, B over A. And that is the major aspect of what we need to learn about now when it comes to geometry with trigonometry. Okay? Okay. So let's do some partying, some examples. So here's a diagram of a right triangle, and we got the trig ratios here. And the question is, what are the sine, the cosine, and the tangent ratios for angle T? Here's how that is written, okay? Sine of T, cosine of T, tangent of T. I'll never forget the first time I learned this, because I had been staring at a calculator like this for years before I had learned trig. And I went, oh, that's what these things are for. Oh. Yes, that's what those buttons are for. We'll get there in the next video. But for right now, let's get familiar with the sine of T, the cosine of T, and the tangent of T. So first things first, we're looking at angle T. That is our angle of perspective. The sine of T is opposite 8 over hypotenuse, 17. Sine of T is 8 over 17. The cosine of this angle T, the cosine is the adjacent over the hypotenuse. The cosine would be then 15 over 17. Remember, these are just ratios. And finally, the tangent of T. The tangent is the opposite over the adjacent, 8 over 15. That's our tangent of T. Pretty straightforward, right? I hope so. I hope so. And you might be thinking, wait, Katz, this is not as challenging as I thought it would be. And the answer is, well, it will be, but hang on. Hang on. Everything's slowly in its own time. Okay, so that's the basics of the operations, of the ratios. So here's another example now. Same diagram. We're going to change our perspective. What are the sine, cosine, and tangent for ratios G? Okay? Now watch, something cool is going to happen. I hope you notice anyway. So let's take a look at angle G now. Here's our angle G. It's way up there. What is the sine of that angle? Sine is opposite over hypotenuse, right? Remember good old SOHCAHTOA. Right? So the sine is the opposite over the hypotenuse. So the sine of angle G is 15 over 17. The cosine of angle G, adjacent over hypotenuse, 8 over 17. And the tangent of angle G, tangent is opposite over adjacent, 15 over 8. Okay? So why is this neat? I hope you see something kind of cool. Remember, both these questions are from the same right triangle, right? We're just looking at the different angles. Notice the relationship between the ratios of the same triangle, but from the different perspective. That's a neat thing that the more you pay attention, the better off you'll be, because that's where shortcuts come in. Okay, so if I give you the sine of angle T, the cosine of the complement is going to be equal to the sine of the given angle. But you'll discover that if you're paying attention. Okay, so hopefully you are. Let's do another example, and then maybe we can see this a little bit quicker. So here's another example. The question is asking, what are the sine, the cosine, and the tangent ratios for angle B? All right, well, if you don't remember Chief SOHCAHTOA, let's just jot that down. It'll never hurt you. Okay, so SOHCAHTOA. All right, so what then is going to happen here? Well, let's take a look at angle B. That's our angle of perspective. The sine is the opposite over the hypotenuse, 5 over 13. Okay. The cosine is the adjacent over the hypotenuse, or 12 over 13. And the tangent is the opposite over the adjacent, or 5 over 12. Okay, remember this triangle, by the way, the old 5, 12, 13 right triangle? Okay. So we have these neat ratios where we're dealing with familiar triangles. So that's from angle B. What if I asked you about angle A? Okay, are you paying attention to stuff? Remember, the sine of a given angle is going to be equal to the cosine of its complement. What? The sine of an angle is equal to the cosine of its complement. So the sine of A is going to be equal to the cosine of B, right? What? Is that true? Let's find out. The sine of A, here's A. Here's our perspective now. So the sine is 12 over 13. What, Mr. Katz? You can't teach us these awesome shortcuts. That's too amazing. I know. The cosine of an angle is equal to the sine of its complement. What? The sine of its complement is going to be equal to the cosine of the angle? Is that true? Let's take a look. Here's angle A. The cosine is the adjacent over the hypotenuse, or 5 over 13. And the tangent of the angle is the inverse of its complement. Okay, so the tangent of an angle is the inverse of the tangent of its complement. So here's the tangent of angle B is 5 over 12. Guess what the tangent of angle A is going to be? 12 over 5, right? It's going to be the inverse of the complement. So how's that work? Here's angle A, opposite over hypotenuse, 12 over 5. And that is the basics of the trig ratios. I'm going to stop here for this video. I want you to understand the trigonometric ratios before we start using them. In the next video, what we will do is begin using these trigonometric ratios to find values. So hopefully you enjoyed that video. Come back for more later. Peace.